so here we go. The nth root rational expressions. Okay, basically 6.1 and 6.2 are introductory to this thing. The whole of chapter 6 is all about roots. All right, square roots, cube roots, fourth roots, fifth roots. The nth root of a, basically what we mean by that is the nth, not the mth, the nth root of whatever that is. Okay, aka we want the square root of a variable, the third root, all right, the fourth root. All right, so if we say something like, hey, the fifth root, we mean, hey, just like a square root, but it's got a little number up there. Cool? What times itself that many times is the number inside. Okay? The index of a radical, okay, that's just another way of saying that right there. Okay? So that's what the index is that number right there. So for the fourth root of x, well, that index is 4. The fifth root of x, well, the index for that one is 5. Okay? It's just a little baseline terminology. That's what we mean. Cool? All right, let's keep on rolling. For actually solving these things, if I have, and I really do not remember what a lot of these blanks right here mean. So basically what's going on is if I am taking the nth root of an x, of a variable, here's what these talking about. If I'm taking the whatever root of a variable, if that n is an even, so like the square root of x, the fourth root of x, the sixth root of x, any even numbered root, if you are less than 0 on the inside, so if I'm doing like the square root of negative x, actually I apologize, let me back to it. You're going to get, let me write it out, you're going to get 2 imaginary solutions. So for example, the fourth root of a negative x is I times whatever the fourth root of x is. Okay? Whatever that happens to be. You're going to get 2 imaginary solutions. If a equals 0, well, if your x equals 0, so like the fourth root of 0, well, that's just 0. I don't care what root it is. If you have the fourth root, fifth root, sixth root, seventh root, eighth root of 0, it's 0. It's because 0 times 0 is 0 times 0 is 0 times 0 is, I mean, it's kind of one of those you probably haven't thought about, but yeah, that's what it is. All right, if a is greater than 0, a is positive, you're going to get 2 real solutions. Okay? So, for example, if we're doing the fourth root of just an x, well, it's plus or minus. You're going to get 2 real, a plus or minus the fourth root, whatever that fourth root of x is. And I'm sorry, up here where the I is, it's a plus or minus up there as well. Okay? So, if you are looking for a variable and you take an even numbered root, you get 2 solutions unless it's 0. Okay? If you are taking an even numbered root to solve for a variable, you will get 2 solutions. All right? If it's an odd variable, if it's an odd integer, an odd root. So for these ones, they are all one real answer. Okay? So for example, so if I did the third root of a negative x, well, that's just I times the third, whatever the third root of that number is. Okay? If I'm taking the third root of a 0, well, that's just 0 every single time. Okay? If I'm taking the third root of a positive integer, well, that's still whatever the third root of that number is. Nothing funky happens. It is just one answer. Okay? Now, again, this only works when you're solving for something. Here's what I mean by that. The square root of 16 is what? What's the square root of 16?
4.
4. Because 4 times 4 is 16, right? Always. Now, if I have an x squared equals 16, this is what I mean when you're solving for an x. To get down to that x, I have to take the square root, right? That is when the plus or minus comes into play. All right? So if I'm just doing a root of a number, it's just what it is. Don't sweat it. But if I'm solving for a variable, that's when we have to start thinking, well, is this an even root or is it an odd root? What's going on with that? Okay, and this will come up later in the period. All right, rational exponents. These ones are easier than they look. These, yes, you can have a fraction for a root, for an exponent. Here's what that means. If I have the third root of x, well, that is x to the 1/3. What it means. The denominator of an exponent is the root. Okay? The top is a normal power. Normal, just like you're always used to. The denominator of an exponent is root. So, for example, if I had the 5th root of x cubed, that would be the same as saying x to the, anybody want to guess? 3/5, because it's x to the 3rd with the 5th root. Cool. And I know the fractional exponent thing might mess with you a little bit. It's going to help out in 2 ways down the road. First of all, that's a lot easier to put in your calculator first. Second of all, when we're combining things, it's a lot easier to combine exponents than it is to combine these things. Okay, it just is. And that's what we're going to do. Cool. All right, if you're still writing, figure out. Otherwise, turn the page. And that's everybody. Let's keep moving. Sweet. So here we go. Problem 1 says find the indicated nth root of a. So they want the 3rd root of negative 216. Okay, so I want the 3rd root of negative 216. So I'm going to ask you this. Can I do the 3rd root of a negative number? Yeah, odd numbered root. I can take a negative odd numbered root. The evens I can't. Those are imaginary. So here we go. I want to do negative 216 to the 1/3. Shove that in your calculator. What's just write 216, the little caret, and then up in the corner write 1/3. Just like that. I wouldn't worry about the negative, because you know your answer's going to be negative. I wouldn't worry about that right now. So what's 216 to the 1/3? -6. So your answer is going to be -6. It's one of those things that, you know, I know that -6 squared is 36. So if I'm squaring a negative, I don't even put the negative in there because I know it's going to go away. This is one of those times, hey, I know the negative is sticking around, so I don't even let my calculator try and screw it up. I just know it's coming around. That's why I didn't.
So we never put the negative?
You can. I just can't promise you what the calculator will do with it. You follow me on that? That's my one worry. Okay? Because again, it's a calculator, it does exactly what it's told, and it might be told to do something strange.
That would be always a negative?
If you are taking an odd root of a negative number, will be negative. An odd root. So like a 5th root of a negative number will be negative. A 7th root of a negative number will still be negative. An even root will be imaginary. All right, letter B. So 4th root of 81. So we want the 4th root of 81. So on your calculator, you're going to put 81 to the what power? 1/4. Shove in your calculator. What do you get? Good. That's it. Cool. Wow. All right, do C and D for me real quick. Do letter C, do letter D for me right quick. What? -3 and 2. Cool. Makes sense. Somebody do that for me real quick. Somebody actually type in -253 to the 1/5. Does it give you -3?
Yeah,
okay.
It does.
I didn't know. If you put it in as a negative, -253, like that in parentheses, that should work as well. You follow? You did it with the other one as well? Okay. So if it works, it works. Oh, did I write 53?
Mm-hmm.
My bad. Thank you. Boop.
If you put it in parentheses, it gives you -3, but and this decimal.
And a decimal? It's actually 243 because I wrote the wrong number down there. It should be 243. So, what's up? Sure. Yeah, it does it. It does it right. Okay, good. That's good to know. Honestly, it's one of those things that I know what's going to happen, so I don't even bother with the calculator with it. Yeah. Anyways, so here we go. Let's move on. Problem 2, it says evaluate each expression without a calculator. Okay, easier than you think. So first things first, let's switch this back to a radical. Okay, so this would be 16. Now, is it to the third power or to the second power? Third power, it's the second root, which we don't have to write the 2 for a square root. So question, anybody know the third power of 16 off the top of their head?
2.
16 to the third power is 2?
Yes. No.
Oh.
Yeah, okay, but let me ask you this. Anybody know the square root of 16? 4. Right, exactly. So here's the deal. You will probably know the square roots of these. So do them first. You don't have to do them in any order. Okay? I know the square root of 16. It's 4, just like you know the square root of a lot of things. But what's 4 to the third power? Do you remember? Yes. We've done that one enough. You should know what that is by now. Some of them you won't, but you should. Okay? So here's my point, is oftentimes it's easier to take care of the root first, then come back and take care of the normal exponent. Okay? You don't have to go either way. You don't have to do them in the reverse order. All right, letter B. 32. What root are we talking about? What am I going to put right there? 5. Good. And I'll keep that as a negative 3. Anybody know the fifth root of 32?
No.
Let me ask you this. If I multiply something by itself 5 times, is it going to get really big? Is that number really big? So it's probably going to be something really small. Anybody want to guess?
3.
3 times 3 is?
9.
9 times 3 is?
27.
27. We got 2 more to go and we're already at 27. So do we think it's 3?
2.
No, it's not 3. I'm not trying to rag on you at all. I'm just trying to show a point. It's 2. Because 2 times 2 is? 4. 4 times 2 is? 8. 8 times 2 is? 16 times 2 is? 32. Honestly, you should probably start learning your powers of 2. So that is 2 to the negative third. All right? Which, let's think of like 2 times 2 to the 1 is 2. 2 squared is 4. 2 to the cubed is 8. 2 to the fourth power is 2 to the fifth power. 2 to the sixth power. 2 to the seventh power. What's 64 times 2? Anybody here do anything with computers? Have you noticed the pattern yet? Like 16 gig, 32 gig, 64 gig, 128 gig, 256 gig, 512 gig. Then you go up to the terabyte, which is 1024, because those are all based upon powers of 2. I'm dead serious. Because anybody want to know why? Why would you think computers would be based on 2 to the something power? What about computers has to do with 2s?
Everything.
It's just a bunch of these, isn't it? It's binary code. It's just 2 values. So they're all 2 to the power of something. All right, that's a total random side segue. But there you go. So honestly, some of you may already know your powers of 2 and don't even know it. Okay? But anyways, back to the problem. So the fifth root of 32 is 2. Okay? So ignore the negative for just a second. What is 2 to the third power? 8. The negative simply says, hey, I'm on the wrong side of the fraction. I belong in the denominator. Okay? A negative root has nothing to do with the number being negative. Nothing. A negative exponent has nothing to do with the number being negative. But all it means is, hey, I'm on the wrong side of the fraction. Okay? Like if I have an x to the negative 2 down here, it means, hey, I belong on top. So that makes it positive. Okay? That is all a negative exponent means. Okay? So here we go. Let's see if you can do letter C.
No, I didn't understand.
Do letter C. This one's positive. Do letter C. Do you understand how I got to here?
Yeah.
Cool. Do you understand that the third root of 64 is 4? Cool. So the only thing beyond there is that. You just got to do 4 to the fourth power, which is that one. Which if you don't know that one, that's fine. But that's what's going on here. Cool.
Oh, we don't. And then we don't put the 4 as a fraction anymore.
No, because there's no negative root. There's no negative exponent.
Oh, okay.
The only reason we did the other one that way is because, is because this guy was negative right there. So if it's a positive exponent, it's on the right side. We don't have to change it. If it's a negative exponent, we do need to move it. That's what's going on. Okay? In that vein, do letter E. And we'll move on to the next one after that. C? Okay, well, everyone else is doing E. C. Do you understand how we got to this step right here? Okay, basically, I turned from this form into that form. Cool? From here, you can go either one. You can either go ahead and raise 64 to the 4th power, which good luck doing that in your head, or you can do the 3rd root of 64, which you should know by now that 4 to the 3rd power is 64. So therefore, the 3rd root gets me back to the 4. Does that make sense? All right, so that's how we got to this line. And then 4 to the 4th, we didn't know that one, that was fine. That gets you to a 256. 4 to the 4th power. Because 4 times 4 is 16 times 4 is it 256 or is it 512?
Yes.
It is 256, okay. Yeah, because 2 to the 8th is 256. That's why.
I just don't get the second part.
This part right here,
Yes.
just take your calculator. 4 to the 4th. Enter, you're going to get 256.
I mean, how you get the 4, the second number?
How do I get this?
Yeah.
I took the 3rd root of 64.
So you put 64.
Well, I just know that 4 cubed is 64. Therefore, I know the 3rd root of 64 will take me back to that 4. Does that make sense? That's the pattern there. All right, so for all of you who are doing letter 9, what'd you get?
Letter 9.
Letter E, doing the 9. What'd you get? 1/3, good. So you turn this into the square root of 9 to the negative 1, which what's the square root of 9? 3. What's that negative telling you to do?
I'm on the wrong side.
I'm on the wrong side of the fraction. I belong in the denominator. And you're done.
What's that?
So we don't do anything with it.
This is the 2 right here. A square root has an understood 2 there unless it says something else. Does that make sense? All right, because it's a square root. That's why, just that way. All right, let's keep rolling. Problem 3. Okay, this is very difficult. Evaluate using a calculator. Round to the thousandths place. How many decimal places is a thousandth place?
4.
No.
3.
3. Don't get me wrong. Somebody every single period has done that. That's the thousandths. They start with 10, hundreds, hundredths. You sound like Sylvester and Tweety. Okay, so literally just type 9 to the 1/5 in your calculator. And you get 1 point something. 1.551, or do you round to a 2? I don't remember.
1.552.
2. There's your answer. Just shove that in your calculator. They say evaluate using calculator. That is what they want you to do. All right. Now, letter B. Okay, we can put that in our calculator, but it's a bit of a pain in the butt. So instead, I'm going to put 7 to the what power?
4.
3 over 4, because it's the 4th root. Shove that in your calculator.
4.304.
Is that right?
Check. 303.
303 or 304?
It's 303, but then like the 5 next to it.
Okay, the 5 would round it up to a 4, because it's got a 5 right there. So, yeah. All right. All right, so here's the deal. There will be people that get this wrong on the test. Straight up. I promise you, there will be. All right? Here's why we put 3 decimals out there. If you're savvy, honestly, you can probably pick up the 4. If you're savvy, you can probably pick up the 0.3. If you're really good, you can probably figure out that the next one's 0 just by trial and error. if you actually get the 4 and get the 4 right, it probably took you so long that you only have half the time left for the rest of the class. That one will take you a while. You follow me? So that's why we want 3 decimal places. Basically to show, hey, you really did put this in your calculator, because there will be individuals who don't. I don't know why. Cameron, I actually believe you will get this one right. Cool?
I wasn't thinking about it.
Oh, okay. I think you will. All right, so let's keep going. Solve for x. Okay, you solve for this just like anything else. If this were just 4x equals 128, what would you do? Divide by 4, just like you do. So what's 128 divided by 4? What's up? 32. All right. How do I get rid of the x to the 5th?
Square root.
Not square root, but 5th root. All right.
I know.
So that cancels out the exponent, which, what is the 5th root of 32? Exactly, 2. Now question, is this one of the ones where I have to put a plus or minus 2 or no?
Yes.
No, it is an odd root. Odd roots only have one answer.
Why you put the
Even roots have 2 possibilities, unless it's 0. What's up?
Why did you put the 5?
The 5th root?
Yeah.
Because they cancel each other out. An x to the 4th, the opposite of an x to the 4th is a 4th root. The opposite of an x to the 5th is a 5th root. They cancel each other out.
So always gonna be the same number.
Exactly. They cancel each other out just like that. So that's your answer. Cool? How did I got to it again? I took. Are you cool with why I did that? All right. Literally, the 5th root of 32 is 2. Or you do 32 to the 1/5 in your calculator. You will get 2. You follow me? That's just what it is. Cool. All right, letter B. Let's keep rolling.
Mr. Hunter, so if the 5 was the 4, it would have a plus or minus 2?
It would have a plus or minus. If it was an even numbered root, you would have to put a plus or minus out there. Okay? Because even numbered roots have 2 possibilities, a positive possibility and a negative possibility. Okay? This is only true when you're solving for x. If you're just taking the 4th root of a number because it tells you to, that's going to be positive. That's fine. All right, so letter B. We're solving this sucker. What are we going to take care of first? The -3 or the exponent?
-3.
The exponent. Think of it like the outside. The exponent's on the outside. So how do we get rid of that 4th? How do you get rid of an exponent? How did I get rid of the exponent over here? It's not square root. It's a 4th root. There we go. Thank you. It is a 4th root. It is a root, yes, but it's a 4th root. Okay? So those cancel each other out. So we get x minus 3. Now, I can't take the 4th root of 21 evenly, so I'm just going to leave it there. Okay? Because it comes out to a big funky decimal. The question I have, is it just the 4th root of 21, or is it plus or minus the 4th root of 21?
Plus or minus.
Good. It is an even numbered root. It gets the plus minus. So you got one more thing to do. What is it?
Add 3.
Add the 3.
Add the 3.
So it's a positive 3 plus or minus the 4th root of 21. And that's your answer. Cool? All right. And if they say round it, then yeah, I would have stuck that 4th root in my calculator. But they didn't, so I just left it because we can't evenly take it. Cool? How are y'all tracking on me? Give me 5 to 1. 5, I got this easy peasy. 4, I'm okay. 3 and 2, I'm lost. Sweet. All right. Letter C. Let's keep rolling. Let's keep rolling. What are we going to do first? Letter C.
Take the 5th exponent.
Well,
5th root. Sorry.
do I take care of the root or do I take care of the coefficient? You multiply by 2. You take care of the coefficient first. Okay?
I hate math.
That's okay. It hates you. All right, so it's divide by 2, so we're going to multiply by 2. And I put that on the video. Somebody's going to catch me and fire me for it. That's okay. So 512 times 2 is 1,000 and anybody know? 24. It's one of those multiples of whatever, 2. All right, so what do we do now?
Divide.
Fifth root it. Take the fifth root to get rid of the fifth power. So x equals, anybody know what that is? 4. Now, is it just a 4 or a plus or minus 4?
Plus or minus. It's not plus or minus.
Is it a 4 or a plus or minus 4?
It's 4.
It's just a 4. It was a fifth root, so it's just one answer. Let me back up a little bit, see what else I have.
So slow.
All right. I want you to do letter D and letter F. Do letter D and letter F.
Mr. Hunter, how do you, like, put that into the calculator?
How do I put this in the calculator?
Yeah, to get the answer.
What's the exponent I'm going to put in? 1 over 5. Just like that.
How do you know if it's positive and negative?
Like the final answer?
Yeah.
If this was a negative 1024, because it's an odd root, it'll come out like that. If this was an even root, it's an I. Well, it would also have a plus or minus out here if it was even. But, okay. So even roots cannot deal with negative. Odd roots can. Cool? But good question.
I.
DNF? You know, I don't want to know. D wrong. Well, let me post letter D real quick, and I'll let y'all look at it.
What?
While I do letter F. I take it that's a lot of people did it wrong.
I did that wrong.
All right, take a second look at it. Let me work out F real quick so we can.
What the F?
Relax. Oh, I get it now.
Oh.
So explain it to us.
Oh yeah, Terry, explain it to us.
I'm not trying to be a jerk. I'm like dead serious. What's going on?
I can give you this
Yeah. All right. Everybody cool with this first step?
Yeah.
Anybody got a problem with that at all?
How you get this?
All right. Everybody cool with this step?
Yeah.
We still cool. What's the problem? One's with a plus, one's with a minus. Negative 5 plus 2 is?
3.
Negative 3. Negative 5 minus 2 is? Negative 7. That's all. What's up?
Okay.
Here, let me post the other one up there too.
Here.
Oh, what you got?
I did the same thing as here, and I got
You're absolutely right. Except the only difference is when you're solving for x, if you take an even root, it is plus or minus the 2.
Oh,
That's the only difference.
Uneven, like the 21 was uneven, so you have to.
Yeah. So yeah, the only reason is we can't evenly take the fourth root of 21, and when we move the 5 over, it becomes a negative 5. That's the other issue. Does that make sense? Which that's just a brain fart, but that you can do. Does that make more sense?
Yeah. Thanks.
Cool. Do we survive letter F as well?
For sure.
Kind of.
For
Kind of, for the most part.
For sure.
Sweet. Letter E. Letter E is a lot like letter B. Can you take the third root of 14? Well, 2 times 2 is 2 to the third power is what? 8. What is 3 to the third power?
27.
So we skipped over the 14, right?
Yeah.
Yeah, so you can't take the third power of 14. You follow me on that?
Yeah.
That's what I mean. All right, turn the page. Let's keep rolling. My record's good. And this one, everyone goes, "Oh my God, words! No." Exactly.
Wow. I can't do word
You didn't get what?
I'm lucky sad.
You didn't record it, or you didn't understand it?
No, I didn't get it on the paper.
Okay, take a few seconds. All right, while she's doing that, let's talk about this for a second. For most of these problems, there really isn't some highfalutin sort of tricky way to make a word problem. A lot of it's like, here's an equation, here's some data, plug it in, get an answer. That's what 70% of word problems are. Here's the formula, here's some numbers, plug those in appropriately, get an answer. Serious, that's what they are. All right, so, you still writing? All right, cool. Problem 5. A hospital purchases an ultrasound machine. Anybody here not know what an ultrasound machine is?
Just kidding.
That is fine. It doesn't matter if you know what one is or not. All right? Who cares? They could say, I'm selling purple spotted tiddlywinks. Who cares? All right? A hospital purchases an ultrasound for $50,000. They expect the useful life of the machine to be 10 years. Okay, it's going to last 10 years. At which time its value will have depreciated to $8,000. So it's like a car. They bought it for $50,000 and 10 years later it's worth $8,000. Okay? All right? The hospital, honestly, that's pretty good for a car that's 10 years old. I don't care what you bought. All right? The hospital uses the declining balance method. Who cares what that means for depreciation? So the annual depreciation rate is given by the formula, blah. The annual depreciation rate. Do you have to know what that means? No. You just know this is the depreciation rate. Who cares what it means? In the formula, N is the useful life of the item. Okay, the useful life of the item. So what does N equal? How long? 10. How long are they going to have the item? 10 years. They're going to use it for 10 years. Okay, S is the salvage value. Well, if you are salvaging the value out of something, that means you're selling it later on down the road. So that's the 8,000. That's how much it's worth at the end. It's kind of like, you've heard of a salvage yard before? That's a junkyard. A salvage yard is where they have all the old cars just piled up, and it's because they have just sold them for parts. If I sell it, I'm going to salvage it for 8,000. Okay? C is the original cost. Well, what's the cost? 50,000. Oh, that's 5,000. 50,000. So plug it in. R equals 1 minus, what goes on top? 8,000. What goes on bottom? 50,000. Which, anybody remember this trick in elementary school where you could just kind of go, oh, I can cancel out my zeros? Anybody remember that? So it's really 8 over 50 to the power of what? 1/10, because it's 1 over n. Sorry. 1 over n is what they give you right here. Cool? So just shove that in your calculator just like that. It is take the equation, plug in what you know, and get the missing variable. Which I think is like... You don't have to. Because they cancel out, you just put 8 over 50. You can. And I think it's... Is it 0.1674?
0.167.
All right, cool. Question. If they asked for this as a percentage, because it is a rate, what would the answer be?
100.
Would it be 1.67 or 16.74?
16.74.
Good, 16.74%. If they asked for it in a percentage, which is another way to ask these questions, okay? So word prompts for this are just plug and chug. All right.